In this video, I'm just going to quickly go over your final data analysis project and report, which will be due at the end of the semester. Throughout the semester, you've been learning about data, what it is, how to present it graphically, how to summarize it, and how to analyze it based on explicit hypotheses. Now you are ready to be biostatisticians. You will choose a data set, and you will analyze it from start to finish and provide a biologically relevant assessment of the results of those analyses. The project will have 6 parts. First, you'll need to give a short introduction to your data. All the data sets you can choose from have an associated historical and scientific context. You'll provide a short introduction to this context. You will also include hypotheses that you are interested in testing based on the context of the data. And then you will provide your methods. You have to choose appropriate summary statistics and statistical tests to analyze your data. In the methods section, you'll include the number of samples collected for each factor group, what summary statistics and tests you'll use, including a detailed justification as to why you're using that test, and the assumptions of that test and any relevant equations. You can use the insert equation on Word to build those equations. I'll show you here. You go to Insert, you go to Equation, you'll pop an equation in here, and then you can use these buttons up here, as well as these, to build those equations. You will then provide the results of your test. You will provide the results in paragraph form, including your summary statistics, statistical tests, test statistics, confidence intervals, standard errors, and p-values. You also need to include relevant figures or tables with proper reference. So for example, if I'm looking at the sepal widths for 2 species of iris, I first show that the observations are normally distributed, and I show that with a histogram in figure 1. And then I give the average width of the iris setosa sepals, which were 3.43 plus 0.05 centimeters, and the average width of iris versicolor sepals, which were 2.77 plus or minus 0.04 centimeters. Those plus or minus, those are standard errors. You can also use confidence intervals, but you need to specify that you're using confidence intervals. This difference was statistically significant, and I provided the test I used, 2-sample t-test, and then t equals negative 9.455, which is my test statistics. My test statistic provided degrees of freedom, which is 98, and I provide my p-value. It was extremely small, so I simply put p is less than 0.005. And then below you have the plot that I produced using R, and I have a short figure legend here. Figure 1, histograms of iris setosa blue and iris versicolor red sepal widths. You will then provide a discussion of your results. Here you state whether your hypothesis was supported by your statistical tests. You also need to provide some explanations for the results that you observed from a biological perspective. So here the example is the differences in sepal widths between iris setosa and iris versicolor may be due to environmental differences between their native habitats. Iris setosa is found farther north than iris versicolor, U.S. Forest Service. This may explain the wider sepals. So here I actually found some information from the U.S. Forest Service to let me know that, yeah, iris setosa is actually has a much farther north range than iris versicolor. I provided the inline citation. In this report, I don't need detailed citations, but if you find information from outside sources, let me know where you find that information from. And then you'll provide an appendix with an R script. You need to provide a separate R file with a full R script that includes all the steps you went through to analyze, including getting the data, summary statistics, plots, and statistical analysis. So the script needs to be sufficiently commented, and anyone should be able to run it without any modifications or errors. I have provided you with a number of built-in data sets that you can use from R. There's nothing you have to download. These are all built into R. These data sets include things like carbon dioxide, the weight of chickens, insect spray data, a bunch of different things. The names are not very descriptive, but what you can do is you can actually get information about the data set by using the question mark function. So here, if I'm interested in the chick weight data, I type in chick weight. Notice that the data set is case sensitive. We run that. And if you notice over here on the right-hand side, I'll make this a little bit bigger. Bring this up a little bit. We have a description of what the data is, weight versus age of chicks on different diets. We have description. We have what the different columns are. So we have weight, time, chick, and diet. We have some details. And then if we look at the bottom, you may actually, if you look at the bottom, we actually may have some examples of R scripts to run and some sources of information. So if you'd like to find those sources, you're more than welcome to. But you shouldn't need to run your statistical tests for this project. You will need to choose one and only one of these data sets. Please don't analyze more than one data set. I suggest looking at them soon and looking at the data and starting to think about it before you make your decision of which data set to use.